Hello, I am Will from the ISIOTO High School Mathematics Study Group. This time, we will be introducing ISIOTO Sensei's relational equations for the dual numbers. Let's go and study dual numbers right away. What I want to tell you guys, there are three things. First is the fascination with real number. The second is automatic differentiation. And third, the relationship between Napier numbers, imaginary numbers, and pi. To begin with, what is the definition of epsilon? In a nutshell, it is a non-zero number that, if squared, is zero. Is there such a number in the range of complex numbers? For a number to be zero when squared, it must be zero. However, this is contrary to the definition from the above. We know it is sort of not in the range of complex numbers. In other words, it's a concept that never appeared in the range of high school mathematics. By the way, engineering faculties often use approximate calculations that ignore terms above the second order as zero. Even in theoretical systems, for example, the formula equation E equals mc squared, which Einstein is said to have been the first to assert, is also an equation that approximates terms above the second order in the same way. So this idea of duality is a rational concept in mathematics. We now consider the CM class function. By using the Taylor expansion, we know that fx plus epsilon is the sum of the derivatives of fx and epsilon multiplied fx. However, for the binomial theorem, we use the fact that the terms above the second degree of epsilon are zero. So what happens if the derivatives is equal to the original function? In the first place, is there such a function? We can think of it as a differential equation of variable separation type, so solving it shows that it is the inverse function of the natural logarithm function. Therefore, we know that is the integral constant times the natural logarithms. Substituting this result into the original formula, we see that the epsilon power of E is 1 plus epsilon. By the way, this formula is very similar to Euler's formula. In particular, the difference is whether the 1 is on the left-hand side or the right-hand side. This means that we can eliminate this 1 by adding both sides. As a result, we see the dual logarithm epsilon can be evaluated by itself, the imaginary unit I, and the pi and Napier numbers. More generally, what happens if we multiply by k? Again, by giving the Taylor expansion, we find that 1 plus k epsilon. In this issue, first we explained how automatic differentiation works. Next, we found the formula relating Napier numbers to imaginary numbers and pi to duals. We also showed that, in general, multiplying by k is the same as multiplying by k. In the next article, we will discuss some applications of dual numbers. Thank you for listening.